Hi, my name is Dominic. I go by he, him pronouns, and I am a first year PhD student in biomedical engineering.
Hi, I'm Justine. My pronouns are she, her, and I'm a first year undergraduate student in biomedical engineering.
Hi everyone, I'm Justine. Today my partner Dom and I are going to talk about how the hand works and how to design your own prosthetic hand.
Some fun facts about prosthetics are first, in 3000 BCE, archaeological evidence of prosthetics are dated back to Egypt and Iran. The prosthetic eye was found in a woman's tomb in Iran around this time. The first prosthetic toe was discovered in Egypt, and that dated back to 1000 BCE, as you see in the image next to me. And Francois de Lannoy was reported to wear an iron hand prosthetic in the 17th century.
For the hand anatomy, so your fingers are called phalanges, and your four fingers, excluding your thumb, have 3 joints in them, and your thumb has just 2 joints. The muscles in your hand are located in the palm of your hand, not in the fingers, and you have tendons running through the fingers. Also, you have 27 bones total in your hand.
So, how do tendons and muscles work together? Muscles function to produce the force that moves our arm, but our tendons connect the muscle to bone, and this connection allows that motion to happen. The muscles in the base of the hand will contract, and this moves the fingers.
So for the design aspects of the prosthetic, there's a few questions to ask yourself. So does it look like a hand or whatever you're designing? And can someone tell that it's a prosthetic? You want the shape to resemble the original anatomy, so it's as functional to a person. And so another question to ask is, can you walk on it? Can you carry things? Can you control it? And you'll be testing that in your own design of your hand. Will you be able to carry something? Can you pick something up, etc.?
And so, how can prosthetics be improved? This is always a question in engineering, and it requires many different engineers to come together and collaborate and brainstorm improvements to prosthetic design. And contrary to popular belief, this is almost never done by one person. You need a lot of different areas of expertise to really come up with a better design. For example, you can have the prosthetic use the patient's brain signals to control the prosthetic like we do with our body. You can try to improve the function and look of the prosthetic. You can improve the strength and weight for, again, better functionality and ease of use, quality of life, and you can make them cheaper.
So now you guys are going to construct your own prosthetic. In this activity, we're going to construct our own prosthetic hand so you can learn more about the design process and biomechanics of the hand. So the materials that you'll need is cardboard or paper, string approximately 1 foot per finger, tape, glue, liquid or stick, straws approximately 5 total, and scissors.
And when you have finished constructing your hand, here are a few challenges and things to think about. First and foremost, feel free to get creative. If you have markers, paint, crayons, or the like just lying around, feel free to use them and customize your design and really make the hand yours. There are some challenges that you might want to try out as well. See if you can pick anything up with your hand. And if your hand can, what's the biggest and heaviest thing to pick up? And to think about that further on, what improvements could you make to increase your grip on objects? How would you redesign this hand to look nicer? How would you redesign it to make, say, a different body part like a foot or a whole arm or even just a single finger? And remember, most important of all, don't worry if your design does not work on the first try. Anytime you try something new, you're really just trying to gain experience and learn from your failure. And it doesn't mean that you aren't smart or that you're bad at it, but that you will try to make something better. And this is very important in engineering. We don't just get everything right the first time. We take make a lot of designs before you see something in a store. With that said, enjoy yourselves and good luck.
Hi everyone, today we're going to be making a prosthetic hand.
To make the hand, you're going to need cardboard, and if you don't have cardboard around, you can use paper.
You're going to need glue. A glue stick will work, or liquid glue may be better.
Tape to hold down the straw components as they're drying and to give them some more stability.
String to thread through the straws that you'll use to pull on the fingers.
Straws to guide the string as you pull on the string to move your hand.
And scissors to cut out the hand from the cardboard or paper. So the first step is to trace a hand. So you're going to line your hand up. Do it, if you can, close to the edge so it makes for less cutting. So when you start tracing, you want to go about halfway to 3/4 down your arm, and then you can just start tracing up. And you can make your fingers pretty boxy. It'll make it easier to cut, and also it'll make it so there's more space to attach the straws.
It will also make your fingers stronger to begin with.
Yes. And you can make your fingers connect also. That's okay. And there you have it. And now once you have it traced out, we'll be ready to cut. Make sure you're always being careful with your scissors.
Okay, so now we're going to talk about hand orientation and joint folding. So if you're a left-hander like myself, I use my right hand to trace around the cardboard and then cut out. And now it's in the perfect orientation for me to operate with my left hand. However, if you want to make this right-handed, all you gotta do is flip it over. And now this will work for righties. And it's the same process for righties as well. You can flip that over and you can make this a left-handed prosthetic.
So now you're going to want to bend these top 4 fingers 3 times. So for each of your 3 joints here. And then your thumb is just going to get 2 folds because it only has 2 places it bends. So for the thumb, you're going to bend it at the base here and then halfway. So you have 2 folds there. Then for the fingers, you can do the bottom fold. You can just fold all together because they'll all have the last fold together. And then you can just about find 2/3 of the way and make 2 folds in. You can also try to, if you want to make them like even, you could kind of do it in thirds like that way. And then you have the joints.
So now we're going to cut out the straw sections for our joints. So we're going to need 5 straws, glue, tape, and scissors.
So now we're going to start cutting for the joints. So you're going to want to measure, put your straw up to it, and it's got to be shorter than like the length of the joint, or the length of the fold. So you can just eyeball it. Each one is going to be a little bit different, but it'll be around the same length. And then you'll just want to glue on. This is where you can either use a glue stick or liquid glue, and you can also put the glue on the cardboard to help it. And then you just stick it in the center, and then we're going to use tape to reinforce, and it works pretty well if you just cut the tape in half, and then you can just tape it on. And also, if you want to make it long enough so that it wraps around the back, it will just make your hand stronger when we put the string through. So then you'll continue this for all 3 joints on each of the 4 fingers, plus 2 on the thumb, and you're going to want to leave 1 straw with space before and after the bendy point for the thumb.
So now we're going to show you how to make the base for each of our fingers and thumb. So you're going to want to measure out about 1.5 inches of your straw. Measure quickly. Just use the tip of your finger
finger so nothing flies off. Still does anyway. And so now you can make your thumb section just like this. And then we're going to glue. You can be pretty generous with the glue, especially if you are using a glue stick like we are. You know what? Get something nice to put down to. Okay. Put it right here. Same process for our finger. Glue this. Glue pretty much a section there. And then we're going to repeat this another 3 times. And so now we're going to want to take a very big piece of tape and place it over the entirety of our face.
It'll give it extra support here. Now for our final step, we're gonna thread the string through the straws. So just gonna go through. It might get a little bit hard through here, but it should be pretty easy. So then once you have it through, you're gonna go around and tie a knot this way. So we're gonna tie like a slip knot. If you know what that is, great. If you don't, doesn't really matter. So you're just gonna go around and loop it through. And it doesn't really matter how much string is here because this knot will slide up. So just like this. So when you pull, you can see the finger start to move. And then down here, because you're gonna want a spot for your finger to hold, just right at the end, do the same thing. And there you go. Then repeat for each of the next 4.
Okay, so now your hand is done and you see it's fully functional. So there are a few things that you can do. Throughout the build, you can take markers and pencils and customize it to how you like and use it to the best of your expression. Or you also have challenges that you could do. Try and pick something up with it. What can you pick up? How heavy is the thing that you can pick up? And think of other kinds of design modifications that you can try out to pick up heavier things, different shaped things, and you might be able to build something better. That's really a very big part of engineering, is creating new versions of designs. And if it fails, that's not a bad thing. You can learn from failures and it can help make your best design. Good luck.